Sorry, how are you?
I'm good. How are you?
Good. Um, all right. I wanted to ask you a question
Mhm.
that was like I don't know how to find it, but it was okay. So the question was something of the sort, like I have the notes on it, so I want to ask, and like I might not be remembering it exactly, but I think like the concept of the question was correct. So like it was a CaCO3 limestone, and it was heated to 1,200 Kelvin. And so then it was asking like what would be the equilibrium constant of the decomposition? And it were the options, I don't remember the options, but I put that like limestone was the equilibrium constant because it had to reach the same like thing, right? Like no matter what it's separated into, it's still gonna have like the composition of limestone. It'll just be in a different form, right? Like broken down.
Uh, you said it was calcium.
Yeah, CO3.
Okay, so that's carbonate, right? Calcium carbonate.
Yeah.
Um, and did they say that it decomposed into like calcium oxide and CO2, something like that?
Yeah, I think so.
So, um, so for the K stuff, we only use we don't use pure substances, so we're just going to have that be the amount of CO2 that's produced,
Hmm.
right?
My issue with the question is like a equilibrium constant is like when you're looking at an equation and both sides have to be balanced, right? So there's something that's like constant to like even it out. And given that you know that it breaks into like calcium oxide and CO2,
Um, well,
like if you pick one of the answer choices like CO2 or calcium oxide, then it would like that can't be the equilibrium constant because that means that the other factor isn't accounted for, right?
yeah, so I think well, like the equilibrium just means that the forward rate and reverse rates are equal.
Okay.
Um,
But the
yeah.
forward rate and reverse rate, so which one is stays the same? Neither of them stay the same though, if it's being broken down.
Yeah, so was it asking for the equilibrium? Maybe they were asking KSP or something like that.
No, it was equilibrium constant for the decomposition, which is what the like heating up was doing. That's when like it was heated to,
It was heated. Okay. So let's
well,
see.
that's yeah, that's when it was heated to like 1,200 Kelvin, and I remember that because that there was a question that was like why doesn't it like decompose it when it's heated to 900 Kelvin? And then there was like a question about like the delta H and like what it meant in relation to like
Was this
T delta S.
was this from a passage?
Yeah, I was doing like questions. I don't think I'm gonna be able to find it.
Okay. Um
Or actually, let me try.
yeah, because there's a yeah. Do you remember what that the answer was?
Mm-mm, that's the thing.
Okay.
Oh, it was from an MCAT that I started taking, but I never finished to take it.
Okay.
All right, I found it. So it was Yeah, so okay, so this was the passage. It was saying like you have the sample of limestone.
Yeah, let's have you zoom out some more. You could do like command or control or whatever minus to go zoom out more.
It's not zooming out.
Like hold
Yeah, I am. It's not moving. Command minus.
like I don't know, for Mac it might be option or whatever.
No, I mean, I was doing it yesterday when I did it, but right now it's not working.
Oh, okay.
Let me, if I go like this.
Oh yeah, you can go there. That here. That magnifying glass at the end of the you could do that too, yeah. Yeah, whatever that key is. What key is that?
I'm not sure.
You see how it's like
Yeah. So that would be command minus, but it's not. Oh, there it is. Now it's working.
mhm.
That's what I was doing.
Got it, got it.
Okay. All right. So all right.
Mhm.
So we had the CaCO3 into a sealed chamber, then heated the limestone to 1200 Kelvin to generate CO2 and CO is
Mhm.
CaO. So my question with this one is, we're doing number one. I remember the delta G formulas, and I think that that's what this was. And H is like heat, right? That's what the H delta H was, that it had something to do with like temperature.
Well, the T would be specifically temperature, right? But the delta H is enthalpy, which
And
it could be thought of as heat energy, uh, but it's you also want to think of it as like the bond energy.
mhm.
Now,
So if it doesn't have like it doesn't have enough heat to break the bond.
now you mentioned something about a formula that you were thinking of.
Like there's equals MCAT, um
Maybe something that includes this.
T delta S. I'm trying to remember the different ones. Yes, okay. Yeah, okay. I did know that one.
Okay.
Gibbs free energy, right? Or something.
Yeah, change in Gibbs is equal to the change in enthalpy minus temperature multiplied by what's the delta S?
Hmm. I'm not sure.
Entropy?
Oh, so it's enthalpy and entropy. Okay.
Mm-hmm. Okay, so now they're telling us that limestone does not decompose when heated to 900 Kelvin, right?
Mm-hmm.
So, um,
So it's between enthalpy change and the product of
oh, I was gonna say,
temperature times and yeah, entropy.
so I was gonna say the delta G, which would indicate spontaneity,
Mm-hmm.
like would have what type of value if it was spontaneous?
Negative.
Yeah. But in this question stem, is this talking about something that's spontaneous?
Well, we don't know.
Well,
But it's also not asking about delta H, G. It's asking about H.
well, delta G is how they come together, right?
Right.
And they're saying,
Don't, no, I'm assuming that at 900, if it's not heated, then it's not spontaneous because it has to reach a certain condition.
yeah, because it's saying it doesn't decompose, right?
Right.
So it's not spontaneous, right?
Mm-hmm.
Means delta G would have to be what?
Positive.
Mm-hmm. So if it's positive, we need to look at what combination of delta H and T delta S would give us a positive value.
For delta H to be greater than T delta S.
Um, okay.
So it has to be positive and greater than.
Mm-hmm. Yeah.
Oh, so that's all you have to do is you have to see like if it's at 900, it won't decompose, so then it's not spontaneous. So delta G is positive. How would that work?
Yeah.
Okay. Yeah.
Yeah. So I want you to be able to know this formula and to think about that when this comes up.
Okay. All right. And then I think, yeah, this was the question that I was like actually struggling with. So CaCO3.
Yeah. So yeah, this one I was able to get the answer from when he just described it to me because we so any K thing comes from that law of mass action, which is like the product over reactants. Bless you.
Thank you.
Products over reactants, right?
Mm-hmm.
But we don't include the pure substances, right?
Mm-hmm.
So what would that be? If you looked at so like step one, right? They have this turning into these two things. Which of these counts?
As a pure substance, it wouldn't be that.
Oh, well, the pure substances wouldn't count.
So would
Mhm.
what's a pure substance? Is like carbon dioxide a pure substance because it like appears in nature or
Oh, so what they mean is so okay, so what will be pure substances would be solids and liquids.
oh, so then the gas
Yep. And
isn't.
also aqueous, if something is aqueous. Because if you think about it, right?
Mhm.
Since like the law of mass action is relating the concentrations of these things, if we have a pure substance, the concentration would have to be 100%, right? So
Yeah.
those don't really play a role here, but yeah, it'll have to be the CO2 concentration here. It's a
That's the equilibrium constant is the one that isn't the natural substance.
uh that isn't the pure substance, you mean?
Yeah.
Yeah, pretty much that. Um so if we were to do it for reaction 2, right, it would be the concentration of this ammonium, right, multiplied by the concentration of this bicarbonate ion over concentration of the ammonia here and concentration of the CO2 here. And we would not include the liquid water here.
Okay.
So all K stuff, capital K, goes back to the what's called the law of mass action. So that's KQ, KW, KSP, KA, KB, KD, all that stuff.
All right.
Yep.
Sounds good.
Mhm.
And then CO2. Oxidation state. I was trying to think of like electronegativity charge, like when you're thinking of like von Goldbrecht, like what form nitrogen likes to take, and I remember it was like 3 and 1.
Well, that you named like the elements that show up as gas as diatomic gases, but when they say oxidation state, um, for something, like you should be able to find it out, right? Like you know, okay, so sorry, so walk me through what you were trying to do.
Like, so it's asking for the oxidation state of N, right?
Oh, you know what? I think you're right here. Yeah.
I wish you could like do it so that it shows the answers
Uh-huh.
if you want.
Well, it's okay. We can rely on ourselves, right?
Mhm.
H3 here means nitrogen is 3 plus, or rather 3 minus. And then NH4 has a plus there, so it's still going to be the 3 minus. But generally speaking, you should be able to know, like the oxidation states within a molecule. Like, for
Mhm.
instance, in this one over here, what's the oxidation state of calcium in this?
+1 or
Well,
-1.
well, all right. How about the OH?
OH has the 2, but that's not. How can you tell? I don't know. I like
Okay.
so
OH
2 because that's not
OH would have OH just by itself would have what charge?
negative,
All right. Now, if we had two, it would be 2 times
-2,
-2. So calcium would be,
-2.
well, the two
It
I
has its own charge though, isn't it? Ca plus.
so we know that the entire thing is neutral.
So it has to be +2.
Yeah.
Okay.
Yeah. So you should be able to tell oxidation states of atoms, in molecules and things like that.
All right. So because this one was overall neutral and hydrogen had the charge of 3, then nitrogen had to be -3.
Mhm.
And so the same thing goes for this because oxygen has the charge of 2,
Negative.
uh, -2, then this one had to be +2.
The carbon in that one.
Yeah. Okay, that makes sense.
Like it would be -2 for each, and we have two, so it's -4, and carbon is +4.
Okay, that makes sense. All right, this one, I'll walk you through how I was working through it. So I was trying to figure out what gas X could consist of, and this might be like a really big stretch, but it was NaHCO3, and so I was trying to like balance the reaction because if you look at like the products, it's H2O, Na2CO3, and then gas X. So I tried to figure out what was unaccounted for in gas X, like from the original stuff, because it had to have been multiplied by 2 in order for there to be like the 2 NAs and the
So this
uh
is this,
second H.
so this is a content thing where you have to know that 1 mole of an ideal gas at STP will have a volume of 22.4 liters.
It has to.
Yeah. Regardless of what that is.
How come?
It's just how it is.
So and then I found the molar mass of like I said that, but when did they say that it's an ideal gas?
Oh, we just treat it like it is.
How come? Because when I found like when I calculated, I found that it was like a carbon dioxide. So then I tried to find the molar mass of that.
Uh-huh. So
And
molar mass would just be the mass of 1 mole of something, right? Um, but so on the MCAT, if they talk about gases, assume ideal unless they tell you that it's not.
So any time we see a question like this about a gas, it has to be, the answer is 22.4.
Well, 1 mole of an ideal gas at STP is 22.4 liters. Yeah. So this question stem tells us STP, so that condition is met, and the passage tells us it's 1 mole. Therefore, we have what we need. 1 mole of an ideal gas at STP has a volume of 22.4 liters. That's going to be true for any ideal gas at STP, regardless of the identity.
Okay.
Definitely, yeah, definitely know that.
All right, sounds good.
Mhm.
I think this is where I stopped.
Okay.
Do you want to keep doing this and then, or just do like regular practice?
I think this would be good because we get to do more, you know, full length stuff.
Okay. One of the optical methods for the measurement of blood glucose concentration is based on reaction 1. So glucose and O2, gluconolactone, H2O2. Reaction 1 is catalyzed by glucose oxidase, and the H2O that is produced subsequently reacts with an oxygen acceptor and creates an oxidized chromogen.
All right, I'm going to ask you a couple of things. What is a lactone?
It's lactose in a different form. It's like missing something.
So it kind of sounds like lactose, but it's going to be a little different. So what a lactone is a cyclic ester.
Okay.
Like, let's say we have something like this, like that.
Okay.
Because you remember what an ester looks like?
Well, it's not. Yeah, I think so.
What would go here?
Oh,
Is that it?
I think so. Or OH, right?
That would be a carboxylic acid, right? OR?
Okay.
Something like this.
Oh, right. Yeah.
Yeah. Oh yeah, you see it in fats, right? So okay, a lactone. So this is what an ester is. So like all of those carboxylic acid derivatives, you need to really know, and have it down. Like, so for instance, like this over here is the carboxylic acid. This is the ester.
And then
What's this?
alkyl.
Well, alkyl is just a general term to mean like a hydrocarbon, but what's this molecule? So you could see like how there's multiple molecules that have the carbonyl group, but attached to that carbonyl would be different things. Okay. What are you thinking of?
I'm trying to just like,
Huh? What's up?
okay. So
Yeah, in the chat I put a little image about the different carboxylic acid derivatives, but you see how, so they all have the carbonyl group, right?
Mhm.
If this thing attached to it is an OH, aka COOH, carboxylic acid, right? You could have an acid halide. You could have, all right, I'll erase what I drew. Acid anhydride, like this. Ester here, amide. Thioester doesn't really come up, and CL phosphate doesn't really come up too much, but definitely need to know, these.
Ester amide. Okay.
And in addition, of course, to like aldehyde, ketone, stuff
Can we
like,
draw out those two? I just want to make sure.
yep. So they'll have carbonyl groups, but if it's just a hydrogen here, that'll be an aldehyde. Whereas if it's, when I use R, I mean it to be like a carbon, hydrocarbon chain. Um, that would be a ketone.
Okay, so there's an R group on both sides. It's a ketone.
Yeah,
Okay.
yeah. And also, when you see that carbonyl group, think electrophile. Remember, we talked about that.
Mm-hmm. Yeah. Wait.
Mhm.
Ketone was nucleophile.
Mm.
We talked about this yesterday. Oh, kinase is nucleophile.
Yeah. Well, the kinase uses amino acids that have hydroxyl groups, which are nucleophiles.
Which that makes it a transferase because it transfers
Uh-huh.
from one thing to the next.
Yeah, and for kinases, particularly phosphate groups.
Okay.
But yeah, so yeah, be able to know these. Yeah, functional groups are really important, so definitely know these. Um, yeah.
Okay. Sounds good.
Right.
Um, oh, it disappeared.
Okay, so I asked you about lactone. What's this?
H2O2.
Yeah, what is that?
A molecule.
Yeah. Hydrogen peroxide.
Is that okay? Hydrogen peroxide. All right.
Like, they're like in those.
No, I know what it is. I'm just saying that like it's not. I didn't know that that was what the structure was.
Yep. What type of bottles are they in?
The brown ones.
What do you think?
So it doesn't react with I don't know what.
Light.
Light. Okay. So that's why it sounded like glass. Okay.
Good. And then they say glucose. It's that reaction one is catalyzed, right, by glucose. Actually, before I ask that, um, what's the oxidation state of the O2 here?
Oxidation state.
Yep, of this O2.
Is it 2?
So it's has a no charge, no net charge, right?
Yeah.
So we could say 0.
Okay.
What's the oxidation state of oxygen in hydrogen peroxide?
It's also neutral, so it's 0.
Well, the entire
The entire thing is.
the entire molecule is neutral, but this time we have more than just oxygen in it.
So then just that one is -2.
Good, because the hydrogen is +1 and there's 2 of them, right?
Mm-hmm.
So if the oxidation state changed, what type of reaction happened?
If the oxidation state changed, then
Yeah.
it was oxidized, right?
So what type of reaction involved?
Oxidation.
Yep. Anything else? Because if you have oxidation, you should also have
Something with the hydrogen, right?
so if you have oxidation, you should also have reduction, right?
Oh, yeah.
So this is a what reaction?
Redox.
Redox. Good. So yeah. Because I was gonna ask you what type of enzyme this is, but then I realized I could ask you the other thing first to also have you figure that out. But yeah, an oxidase is what type of reaction? Sorry, what type of enzyme?
Oxidase.
Yeah, what enzyme class?
And isn't that one of the, like we were looking at it was transferase, reductase and oxidase. They're,
Oxidoreductase, yeah.
yeah.
Good. So yeah, because I was gonna ask you what type of enzyme oxidase is, and then I was like, oh, I could actually ask you the thing about reaction 1 so you can see that it's redox. And then it would make more sense for it to be oxidase. So right away, we get to see these things, and those are things that you want to be thinking of. Those are things you want to know. So you can continue. Or I could also ask you, no, yeah, you can continue.
Um, where was I? Oh, oxygen acceptor and creates an oxidized chromogen. The optical absorbance is affected by the oxidized chromogen and thus provides the information on the glucose concentration. In a test, a blood sample with a 1:30 dilution ratio.
Tell me what that meant.
What the 1:30?
Oh no, just that what you read in that second paragraph.
So that this chromogen that got oxidized gives us the information that they're looking on for the glucose concentration. Like they do this reaction in order to measure it, which is what they were talking about over here.
So they do the reaction, but then what happens?
It reacts with an oxygen acceptor.
What reacts?
H2O2, so that would make this the oxygen accept. No, what?
You see what I'm underlining?
Yeah, but that is what reacts with the oxygen acceptor
Yeah.
and
Right.
creates an oxidized chromogen.
Uh-huh.
So this is the redox reaction. That's what they're talking about here.
Well, the redox reaction is what reaction what?
Glucose and O2.
And that produces the hydrogen peroxide.
Yes.
And then the hydrogen peroxide that's produced reacts with an oxygen acceptor to create an oxidized chromogen.
Okay.
So yeah, so we have reaction 1, and one of the products of reaction 1 gets or reacts to make something, an oxidized chromogen.
Okay.
Hmm.
All right. And then that gives us the glucose concentration. And then I was reading.
Sorry, I want to ask you this also. What's happening to the oxygen here? Is it getting oxidized or reduced?
Reduced because it binds to hydrogen.
You could also think about it in this case by just looking at the oxidation state. And it goes from 0 to negative, so it's gaining electrons, which means it's getting reduced, right? And then they say that the hydrogen peroxide reacts with an oxygen acceptor and creates an oxidized chromogen.
Mhm.
So that likely is the hydrogen peroxide getting oxidized this time, but we don't know for sure yet. But yeah, this chromogen has a certain optical absorbance, and that can give us information on the glucose concentration. So okay, cool. And then you're starting the next paragraph.
Okay, so this is the one where it's talking about the blood sample getting diluted in a transparent cuvette with an oxygen acceptor solution containing glucose oxidase. So
Mhm.
with an oxygen acceptor solution. So that's what's going on here.
Okay.
All right.
Do you remember or know what a cuvette is?
Yeah, it's part of like a chem lab. It was like a little like I can't like it's not a beaker, but it's
Yeah, it's like a little
like
rectangle.
the thing where like you press it and it like releases just the amount that you.
Oh, you're thinking of that tool? No, it's like the transparent, like little rectangular container that you put
Yeah.
something in, and then you can measure absorbance with Beer's law.
Okay. Yeah.
Yeah. So
All
they
right.
so they took a cuvette and then they took blood and they diluted it, and they put that blood sample in addition to an oxygen acceptor solution that contains that enzyme.
Okay.
All right. And then they added the same mixture to 5 other cuvettes with identical optical properties containing solutions of known glucose concentration. So, okay.
Okay. The same mixture was also added to 5 other cuvettes with identical optical properties containing solutions of known glucose concentration. So, oh, at different levels of the concentration.
Mm-hmm.
All right. A spectrophotometer measured the intensity of light passing through the solution as a function of wavelength. Okay. Absorbance is defined as this, where is the intensity of the incident light and is the intensity of the transmitted light. Okay, so they're just giving us like the parameters of the equation.
Okay.
Okay. Measurements made in the entire visible spectrum showed the absorbance occurred at a wavelength of 625 according to the data in table. So it would be like indigo or violet, like it would be after blue on the visible light spectrum. I don't know if that's going to be a question, but I
When,
had one
whenever
actual cat where it was like 625. Like if you're looking at like what color would that be?
good. Whenever they give you wavelength of light, do you remember what 2 things I told you you can find if you had to?
Um, that you should know like the range of Roji Biv, and then you should know where like micro is.
Well, Yeah, you definitely have to know that stuff, but if you're given wavelength of light, there are two things that you can solve for without needing any more information.
I don't remember what those things were.
So what are some equations that come up with wavelength of light?
Oh, how like if you have what was on the equation? It was lambda
Okay.
and then but that's when you're solving for like frequency.
Okay. Is it true that you can
You
solve
can
for,
rearrange the equation with like when you have those things.
so is it true that you can with wavelength you can calculate um frequency?
Yes.
All right.
You need
What else can you calculate?
um
Think of a formula with H in it.
equals HC over lambda. Okay.
What's this?
Energy of a photon.
All right. So if we were just given wavelength, right, we would be able to solve for the energy of a photon, right? Are you seeing this?
Yeah.
Right? And we would also be able to calculate what?
Well, C is the constant, right? So if we have the energy, then we can solve for H.
That's also a constant, right?
Okay. Frequency, we can only solve for frequency.
Yep. So anytime, so you're going to be given light wavelength a lot on the MCAT, and I just want you to know whenever you see that, if you had to, you can calculate the energy of that light, and you can calculate the frequency of that light. Okay.
Okay.
So remember that passage that we did the multi-plate thing? It was like um sorry, no, it was the one on, I think, yeah, it was the multi-plate. It was like with pulsed radiation or whatever, or maybe that was a different passage, but it was something where they basically gave you the wavelength, they gave you the power, and they gave you the pulse laser time.
Okay.
And in that question, in that passage, we had a question that asked us to solve for energy. And what we did was,
We set power in like an equation with frequency, right?
so the power is energy over time.
Yeah.
So power times time would give you energy, right? So that's how we did it. But and I didn't say this at the time, but we could have also just used wavelength to solve for energy, right?
If those two things are constants.
If what two things are constants?
If H and C are constants, then
Yeah, H and C will always be constants, right?
right. So, well, I'm not thinking, I guess, because I don't know what the
Uh,
okay. All right.
what were you saying that you didn't know?
Like I don't like know what the values are, but I guess that makes sense.
Oh yeah, yeah. So the values, I mean, they'll typically give it to you, but you should definitely know. So like I'll tell you as well, but you should also know at least C. C you definitely have to know. What do you think that is?
Hmm.
So something that could
Speed of light.
yeah,
No, that
I meant like the value.
was like times 10 to the something. So,
Yeah, most things will be times 10 to the something, right?
mhm.
But
What it is, I don't know.
okay, it's 3 times 10 to the 8th meters per second.
Okay.
So something that gets, which is 300 million.
Hmm.
So what can help is, well, two things. Maybe like the population of the United States is around 300 million. I think it's like 320 million. It's roughly that way, that amount. But also the speed of sound is like 330 meters per second. So the speed of light is a million times faster than the speed of sound.
Yeah, which makes sense.
Like yesterday, there was like kind of like a thunderstorm.
Right. So you see it and then you hear it.
Yeah, yeah, yeah. Okay. Good, good, good. So yeah, just know whenever you see, I want like basically like if you see a OH group, I want you to think nucleophile. If you see a carbonyl group, I want you to think, electrophile, partial positive, partial negative. If you see a wavelength of light, think, okay, if I needed to, I can solve for the energy of this light. I could also solve for the frequency of this light. Okay. These are just like things you want to be, that you want your brain to kind of pop up in. You want it to pop up in your brain. Okay. So they give us this absorbance equation. They give us the um absorbance being just at this wavelength. And then we have table one. And yeah, what does this table say? It says absorbance of standard glucose solutions and of a diluted blood sample. So what do you see in this?
I'm seeing the different like levels of the rates of absorption and then like at a specific concentration. So like 0 was 0 and then when the concentration was 1.5, that was the absorbance rate. So it's kind of like linearly going up.
Yeah, right? Because we see like, this doubles, that doubles, right? This doubles, oops,
And that
this doubles, right? So as you said, we see a linear type of relationship. Good. And we also see that, you know, absorbance would be proportional to like glucose concentration because if absorbance goes up, so does the concentration of glucose. Now, okay. Yeah, and then yeah, you could read underneath.
the M equals 1 diffraction maximum was observed at an angle of 30 with respect to the line perpendicular to the transmission diffraction grating used in the spectrophotometer. I remember you were telling me about like the angle of incidence, right?
Uh-huh.
Where like if it went over at a specific angle, like that meant like the way that the light would get reflected. Okay.
Yep. Right. Cool. So, any questions so far?
No.
Okay.
Um, I'm looking at the question. Containing identical optical properties. So I don't think it's the wavelength or increasing the absorption.
Okay.
Or reducing the absorption in the glass walls. Like it's not, it's just being able to compare it, right?
Yep. Because you want to, you want to keep it constant if you are to compare them, right?
Right.
Good.
Energy of a photon absorbed in. Okay, so
Yeah, they love asking these types of questions, right? So that's why, when you see that wavelength amount, you want to be thinking of things like this.
okay, so we have the wavelength. We said to use the angle.
So what did
So we
we?
only have the wavelength
Yep, but what was I saying about wavelength?
that you could use it, but don't you have to know what the um oh, they give us HC.
Yeah, but HC you would know as well, right? They're just constants.
Right.
So remember how I said if you're given wavelength, you have all you need to calculate either the energy or the frequency. And that shows up right here. And you're gonna see this show up all the time. So just get into that.
I understand that like how the equation works, but we said that energy of a photon is equal to like HC over lambda, right? So then
Yep.
you plug 625 into like as lambda, and then you have HC in the numerator.
Mhm.
So then do you divide that out and that would give you, if it's the 19,
When you say the 19?
this.
Uh okay. What are you thinking?
I think it's A.
Walk me through your math.
Um, well, I genuinely did it like a lot more complicated than it needed to be.
So what did you do?
Well, I set it up as 1.6 times 10 to the negative 9th is equal to 19.8 times 10 to the
Negative what?
negative 19th.
Okay. And what?
Is equal to 19.8 times 10 to the negative 24th
Hmm.
over,
So equals like this, or what did you do?
well, yeah,
Oh, you just wrote equals?
yeah. 19.8 times 10 to the negative 24th over 625. 26. Oh, okay.
25 what?
So then
What,
what
25 what?
nanometers.
Okay. Now what?
And then
So you know that
trying to like balance it out and
you have
solve it in my head.
nanometers down here and meters up here.
Yeah,
So,
you can
and then this,
solve it out, but just what I was trying to do is moving like the decimal point
and
of joules and meters.
this is what 1 electron volt is, which is
Yeah.
not what,
And energy
yeah.
photon
Let-
is.
Let's talk about how to set up these types of problems. You want to, I know that, you know, the physics that they teach pre-meds is like all about like plugging numbers into your calculator and stuff.
Mhm.
But I think it's best to write things out algebraically and plug things in at the very end. Because if you plug things in right away, then there's prone to be mistakes in terms of setting it up. So let's think about how we can set it up algebraically, right?
Mhm.
So how can we do that?
Well, we would, okay, so if we're doing that to avoid confusion, it was energy of the photon is equal to hc over lambda, which is the same as like,
Which go on?
mm,
So okay, let's plug
is
in.
that,
Yeah.
I don't know, like,
What's up?
is it easier to solve for the frequency? Or no, you can't.
You can. Remember, if you have wavelength, you could solve for frequency or energy, but they're
Right.
asking us to find energy, right? So we can just solve for that. So look, why don't we do this, right? Why don't we, so we have hc over lambda. We know what hc is in joules and meters. We have lambda at nanometers. We want the lambda to be in meters. So we have the ability to do the math, right?
Mm-hmm.
So let's write, and 19.8, like let's just write 20, right? 20 times 10 to the, oh yeah, you have like a time warning here. So you have 20 times 10 to the negative 26 joules times meters over, now for this 625 nanometers, we want to write it in meters, right?
Yeah.
Okay.
So nano was to the power of 6.
So be careful with that. The um okay, so like milli would be 1,000th, micro would be 1,000,000th, nano would be 1 billionth. So
Mm-hmm. Okay.
yeah. So nano would be,
E to the negative 9.
yep. So I would write 625 times 10 to the negative 9 meters. Right?
Mm-hmm. All right.
And doing this math will enable me to get the answer in joules. Right?
Yeah, because then you can cross out meters.
Exactly. So now how would we do the math here?
You would Where was, oh, our joules left, the electron volts you took out.
Yeah, I'm just doing it in 2 steps here just to avoid confusion because before I think yeah, I can show you how to do it in 1 step after we do it in 2 steps.
Okay.
So I want to know how you would do the math here.
Wouldn't you just cross out, like divide out the meters?
Well, yeah. But tell me, what do we do with the numbers?
What do you do with the numbers? You divide them.
Yeah, how? So tell me, walk me through.
Oh. So it's 20 e to the negative 26th over 625 e to the negative 9th, and you could expand on the 20 and make it larger so that you could do the division, or you could make 625 smaller by doing it to like e to the negative 11th, right?
Sure.
So that would be like roughly 4, a little bit less, 3.
We could divide top and bottom by 10, right? To get 2/62.
Okay, so then it's all right.
And what can we do with
And then with the signs, you do you like
well
subtract them.
before
Like
that,
what?
what do we do with the 2/62?
Oh, well, it would be 1/31.
Excellent. And what would this be like as a decimal value?
Like something really small, it would be like less than 0.1, right?
Yeah, so give me like a little like point what?
They gave like point, like 1/30. 1/3 is 0.33, right? So this would be 0.00, like 0.03.
Yeah, good. And that's exactly how you should be doing it. Think 1/3 is 0.33. 1/30 is 0.03, right? Good. So I would write that first. And then I'll deal with the exponent. So now what do we do with these exponents?
Now you subtract them.
Okay. What do we got?
We did 26 minus 19.
Make sure.
No, I know. So it would be plus because they're both negatives. So it's to the negative 45.
Well,
Oh, not 19. Wait, 9. Sorry, I'm looking at the EV one. So it's 26 plus 9.
yeah, negative 26.
Oh, yeah, so it's negative 35.
No, negative 26 minus -9 would be negative 26
6 plus 9.
9, which would be
17. Negative 17.
yeah. That's why you want to you don't want to rush any of the math stuff because it's really easy to make mistakes, right? So
Mhm.
now this would be the answer in joules, right?
Yes, but we don't want it in joules. We want it in electron volts.
Yep. So now we can convert. So 0.03 times 10.
That would be the same as like 3, right? Because it's to the negative 19th. If you move the decimal point 2 places back, you get negative 19.
Again, don't
1.6.
rush this.
So then 1.6 divided by 3, and it's 2.
Okay, yeah. But yeah, definitely don't rush this because you were kind of saying like the answer was 1 electron volt, and then you were kind of trying to you said something like 3, but those weren't the just do it really slowly and
You
systematically.
do it slowly. All right, so let's say I'm looking at this. Can you erase it? I just want to like think for myself how I would solve it. So we're looking at the energy. Okay, so we're looking at the information we have. We see that we have the wavelength, and we're looking at the equation, which is energy of the photon is equal to HF, or we can rewrite it as frequency is equal to C over lambda. So we have E photon is equal to HC over lambda. HC we have, it's given to us, it's 19.8 times 10 to the negative 26 joules per moles. And I have to be careful with the units because the whole thing that we were just doing was crossing out like first meters and then joules. Okay, so it's 19.8 over the 625. And then you did it as, you wrote it as like 20 at some point, right? Or no, you did 1. Why didn't we do 20? Was
I
our calculation wrong?
I made this number 20 because it's
You
based
did make it 20?
this number, yeah.
Oh, yeah, but that's what I was saying, because I thought like when we solved it out, it was 1 over the thing. Okay, so we did that. We wrote 20 over 625, and then we did it as a multiple of 10.
If by that you mean we did the scientific notation for nano being meter.
No, I thought what we did next was oh, we did the nanometer
Yeah,
to
you
get
have to
it
make
into like meters instead of nanometers. And since nano is e to the negative 9th,
yeah.
we rewrote it as that. Wait. Plus or minus, this is the standard deviation, right?
Yeah.
Okay, so it's 625. Or 620, whatever. So that's how you got that when you were doing as a like multiple of 10. So then we divided them out.
So when you meet, so you're saying this, I did this, right?
Yes.
Yeah.
But then when we were looking at them, we put one over the other. We did 20 e to the negative 26 over 625 e to the negative 9.
Yeah.
When you were taking them out, you did 20 out of the top and left it as like 1 over. And then the bottom was 625 divided by 20. It's like 30,
Mhm.
300. No, 30.
Okay.
And then we had to
When you say
add
30,
9.
when you say 30, you mean 1 over 30?
Well, yeah, it was 1 over 31 when we did it.
Yeah.
So like 1 over 30 is fine. And then you have to add the units. So it was negative 26 plus 9, and that gave us negative 17.
Okay.
And then I noticed that so that gives us the answer in joules, and we need it in electron volts. So I was looking at this equation and I saw that negative 19, and our answer was in negative 17. So if we moved the 30, if we made it into, it would have been 0.3, not 30, not 3, the way that I was thinking.
Well, the 1 over 30 would be the 0.03.
Oh, right, that's the step that I was missing. So you have to convert it from fraction to decimal.
Yeah. That's you know,
Okay, so you convert it from fraction to decimal, and so it's 0.03 times 10 to the negative 17th, or you can write it as 3 times 10 to the negative 19th. And given this equation, 3 divided by 1.6 is about 2, and that gave us the answer B. So it's
yeah.
very time consuming, but okay, that makes sense. So I know this equation, so this should be an answer that I can easily get.
Which equation?
Have to be like the E photon equation.
Yeah. Were you like, did you know it like beforehand when you were trying to this? Like,
Well, I didn't get up to this. I had to stop like almost immediately after started. That first paragraph was the only one I did it. This is my first time seeing the question.
no, I just mean when we were just doing it together.
Yeah, I remembered like lambda and I just didn't remember like HC, but I know it now. I'll be fine.
Yeah, yeah. I just don't want you to
Forget it.
rush through things.
I know I have to take my time and solve it out. Okay.
Yeah.
According to table 1, what is the concentration of glucose in the blood from which the diluted sample was taken? Concentration of glucose. Isn't it 1/30?
What?
Because, okay, so it's a 1/30 dilution ratio of milligrams to diluted. And the absorbance is 20. Do they want us to use this equation? Or is that like too much? So
Yeah, so what is this question asking?
concentration of glucose in the blood at like from which the diluted sample was taken. So
Okay.
the blood sample with so it's this line that we're looking at.
Okay.
And it's but I'm just asking if like the absorbance is what they're looking for, or because these the glucose concentration would be around 5 if you look between these two, or it would be like 4 point something. And then I think that you have to plug that into the 1/30 to get one of these.
Okay.
So let's say 30 times 4 is 120, but it would be a little bit bigger, so it would be 150.
Excellent.
Okay. So it's just like educated guess based on like where these things fall.
Uh-huh. Yeah, and this could have been tricky if you didn't see the from which part, but you got it.
Well, as soon as I saw that like it was concentration, the diluted sample, I looked at this equation and it was 130.
Uh-huh.
And then this whole chart is taking, like, I knew that it would have to look at the diluted sample, and I didn't think that it was like the absorbance, but these ones, because it's literally saying like concentration of glucose, glucose concentration, and the answers are all in terms of these. But
Mhm.
then I don't know, I thought this equation was a okay.
Mhm.
All right. Suppose a blood sample tested it above the range of the standards used in the experiment. What modification will provide a more precise reading by interpolation to or as opposed to extrapolation using the same standards? Um, when you take blood, you measure the O2 levels,
Okay.
like in like a hospital setting, like it has to do with O2. So I'm assuming that that's what we're gonna look at here, that it's something to do with oxygen. But oxygen acceptor, because that's it's not what's happening. Oxidized reacts with an oxygen acceptor and creates an oxidized chromogen. Absorbance is affected by the chromogen and then provides information on the glucose concentration.
Okay. What's meant by interpolation and
You
extrapolation?
add something instead of taking something out.
Um,
Extrapolate is like when you can extrapolate the data. You
Okay,
Like
more?
extrapolating is like the result, right?
Like, let's say that we had whatever, like, this is the 4.5, this is the whatever value for the diluted sample, and then this is the 6. And, let's say that it makes this type of line of best fit.
Mm-hmm.
And if we were to try to figure out what the absorbance would be, let's say absorbance here and, glucose concentration here. If we,
There has to be something reacting with something else that we can like have this whole thing happen, right? So if we're like, how do we have more product? We have to add more like more react like something for the reactant to like react with. So I think more solvent,
okay.
right? Because it has to have something to do with like adding something else. It wouldn't like be changing. I'm thinking of this in terms of like the ES complex where like there's certain things that wouldn't change.
Mhm.
And I think pressure would stay the same,
Okay.
right? Because the pressure of oxygen. And then I don't think that enzyme concentration has to do with it either. So yeah, I'm sticking to D.
Okay.
Is that right?
Hmm.
You just got so quiet. You usually have so many opinions to share.
Oh yeah, just as I wanted to see if you wanted to know the difference between interpolation and
Oh,
extrapolation.
definitely, yeah. So that if it comes up again.
Yeah, right. Because so we have data until 6, a glucose concentration of 6, right?
Mm-hmm.
So if we were to, let's say, let's guess what the absorbance would be at a glucose concentration of 7, we would use like this line of best fit to figure out what value would be for something that is beyond the range that we've already measured for.
Mm-hmm.
So that's extrapolation. Okay. But for like this diluted blood sample, which is between the measurements at 4.5 and 6, that is interpolation.
Because it's taking away.
Oh, just because it's in between.
Okay.
Yeah. It's like
Okay.
we can figure out through interpolation what the glucose concentration would be at an absorbance of 0.14 because it's in between values that we already know, right?
Mm-hmm.
So, yeah. So that's interpolation versus extrapolation. Yep.
Okay, sounds good.
Yep. How are you with like separation techniques and uh things like that?
I'm gonna see if I can figure this out.
Mhm.
It's butanol is like an ethanol, right?
Um, when you
Is
say
it
that, you mean yeah, if
like
it's
what?
it's an alcohol.
Yeah, well, I'm thinking it's an alcohol. So that means that alcohols have how does distillation work? You
Mhm.
fractional. Okay, I'm thinking distillation. You boil things, like you heat them up and it like creates a different kind of solution. So then one has to be higher than the other. Think about structure of butanol versus chlorobutane because there's chloro. I'm gonna think that, wait, I don't know the structures of these things though.
I think you could have a good idea, right?
Ethanol. is,
Yeah. So the OL means there's a OH in alcohol, right?
yeah. So
So
it's like double a bond of O and then the OH on the end. But
wait,
I thought that that was in
double bond?
like when you're drawing it out, but I'm okay. And then chlorobutane. Wait, but that's ethanol. Butanol would be different.
Oh, ethanol is this. F means 2 carbons. Bute means 4.
Okay.
And the OL means alcohol. So
Oh,
group
okay. And then so the same for butane.
for
And
the
then
butane would be
right?
this.
Yeah.
Um, but if
Okay, now I'm thinking Funkelbush.
what 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 makes you think of that?
I think of that all the time.
Yeah, I know. I think you mentioned it 3 times.
Um, okay, so now which one would have the higher melting point? Because it pretty much comes down to OH versus Cl.
Yeah, so
And
you're
which one?
yeah, sorry. Yeah. So how are you able to determine that it's boiling point that we're looking for?
How was I able to? Because I don't think that alcohols have a charge.
Well,
Or
neither do, you know,
well, because that makes it non-polar. So A is wrong if it doesn't have a charge. But then B is wrong because how would that help you separate them? If
well,
they're both non-polar, that's just like a classification.
what do you mean by charge though? Because being polar doesn't mean that it has a charge really,
I
right?
thought the polarity was like one of the factors of it, like when you're looking at amino acids, at least like that, um, it's like the charged amino acids are all polar.
So we don't really put them in the category of polar though.
We don't, we put them in the charged category, but
So I have like a word that I use that is a better way of looking at polar, but polar, yeah, it wouldn't. So what would something that's polar, what would make something polar?
mm,
So okay, you could have full charges, but for polar substances,
like partial, right?
yes, yeah,
Partial positive.
yes, yeah. So, um,
So partial charges are associated with polarity.
exactly. Yep. So, yeah, they kind of made this question like these two choices like very like obviously wrong because they're totally different, which is going to be like making it lucky for us, um but if they said like, chlorobutane is nonpolar and butanol is polar, how would you know that this would not be your answer?
If we didn't, if one was polar and one was the other.
Yeah, like because for
Well,
instance,
because I started looking at distillation and that distillation is associated with that's what we were talking about. That like distillation is heating something up to separate to like make it into a different substance.
exactly, yeah. So separation techniques, distillation takes advantage of the difference in boiling points,
Okay.
whereas chromatography would take advantage of the difference in affinities for either polar or nonpolar solvents. Okay.
Okay. And now but I'm still between C and D, where it's between Cl and OH, which has a higher boiling point.
Mm-hmm.
And
Yep.
I have no idea.
Okay. So higher boiling point should mean stronger intermolecular forces. And the strongest intermolecular forces, hydrogen bonds.
What?
Sorry. Um, so I was saying the strongest intermolecular force would be hydrogen bonds.
Oh, well, that's the most common. I didn't know that it was the strongest.
It's the strongest.
Okay. All right. So then that makes OH stronger than Cl,
Yep.
which is what D is saying.
Yep.
So I had a lucky multiple choice click.
Yeah, that's why I'm so like, if this wasn't the case, I still want to make sure that you're able
Okay.
to answer.
It's like about to kick me off of this. I'm gonna reset it anyways, but when did we start at 3:30?
Sure that they don't let you pause it or whatever.
I know that if I was to have, well, I can pause it,
Oh,
but
yeah.
it's not gonna
Oh,
let
but then
me.
it'll kick you out.
I can reset it,
Yep.
but yeah, should I?
Mm-hmm.
Why is it saying time remaining? Oh, because
For the other sections, I guess, maybe.
okay. So if it was like that, I would have been able to.
Yeah, do you like doing anything during those tutorial sections? Like writing?
Well, on the day of like the actual test, I am gonna look through it just to like make sure to refamiliar myself. Like when I'm taking these practice tests on a Mac, I understand that like a lot of the functions that they want you to use don't work. Like control next doesn't work.
Yeah.
And I don't know about like the highlight and strike through, but like it definitely does take a lot of time to like go and like highlight strike through. So if there's like I know it's like control or alt H
It
and I
looks
don't have that on my
like
computer.
that Mac equivalent is, but yeah.
Yeah, but like when I try to do like the Mac equivalent, which is usually a command, it like doesn't work. Command N just opened a new tab on Chrome and I was like, okay,
Oh,
so
I see what you're saying.
this isn't what's supposed to be happening.
Mhm.
Okay, did these well, okay, it's just following oxidative transfer relations is unlikely to occur. This is like the orgo, like that's fundamentally lacking for me. But
This is like that generalized biochem redox pathway I talked about.
is it the one that you sent me a picture of?
Um, there is a PDF of it in the PDF folder, but I went over it with you once. It's like basically you start off with an alkane. If you oxidize that, you get an alkene. If you oxidize that, you get an alcohol. Oxidize that. Depending on the type of alcohol, you'll get different types of things.
Okay, so
Yeah, I was also gonna say like in that the first.
my thing is that I'm confused about like alcohol to ketone.
Uh-huh. Yeah.
I,
Tell me more.
I think like in my head immediately like that was like the red flag, but I think that they can go to ketone. It just like the level, right? Because there's if you look at the answers, there has to be something with like primary, tertiary, secondary. So tertiary has a tertiary bond with the oxygen, right? That's what the tertiary alcohol means.
It would mean that,
There's three branches. Okay, yeah.
yeah.
Um, so which one's wrong?
Hmm?
Tertiary versus secondary. You said something about this, I remember.
Mhm.
I'm gonna guess D.
D.
Yeah.
So
No, that like D can happen, and tertiary is the one that's like,
yeah.
But can you explain that?
Yeah, because okay, let's say so. So primary here has a hydrogen here, right?
Right.
So if it gets oxidized, we're going to increase bonds to oxygen. So that would just be an aldehyde, right?
Mm-hmm.
And
Which
that,
makes A correct.
mhm, yep. And then a secondary alcohol here, same thing, but we already have, instead of a hydrogen, just two carbons or whatever. So that's your ketone.
Yes, that makes D correct.
Yep. But
And then
tertiary can't, because if we're making a new bond, right? And carbon can only have 4 bonds. So in a tertiary compound, carbon
it
has,
already has.
yeah, the 3, right? So
Right.
if we did this, this carbon now has 1, 2, 3, 4, 5 bonds, which is impossible.
Right.
Mhm. Yep.
Okay. And what about this one, aldehyde to carboxylic acid? This is just like the chain of reactions.
So the aldehyde can turn
COOH.
into yeah,
Yeah, okay.
which can ultimately turn into CO2. But
Uh-huh.
there's also stuff that they could ask you about weak oxidizing agents versus strong. Same thing with reducing agents. So you could see like a weak oxidizing agent would turn it into the aldehyde, a strong one would turn it into like the carboxylic acid. And same thing for reduction, weak one here, strong one here. Okay.
Yeah, all right. So that makes C possible too. All right, so then B
Mm-hmm.
is
Good job.
okay. Let's think this through.
Mhm.
Bute we said was 4.
Wait, what was that?
Bute was 4 carbons.
Mhm.
This has 5.
As its longest chain, good. So that means we could eliminate, or yeah, you could,
And eliminate C and D.
good.
I'm assuming that the 2 comes from the double bond here.
Mm-hmm.
And then what does C or E mean? The classifications.
Mm-hmm.
I'm not sure like the difference between Z and E.
Oh, yeah. So Zusammen means that they're going to be on the same side um of the double bond in terms of the higher priority groups. And
What
E,
is on the same side? Like this?
yeah, yeah. Something, yeah.
Okay. And so it's not, so then it would be E, the opposite side.
Oh, sorry. So I mean, okay, so like on opposite sides, I mean more so like if this is the line between the two,
Uh-huh.
right? And rather than both sides like that. So if this is the line between the two, we see that on the side that's to the left of the double bond, um, the higher priority group is here. Uh,
Okay.
and then
It is on the same side.
on the right, the higher priority group is here. And they're on the same side of the double bond. So that's going to be
But I thought you just said that it's on, that it's not like this, it's like this. So wouldn't it, you said that it was based on this group.
Yeah.
Oh, but there's no, so you're looking at like this is like your center and you're looking at the priority group. So this one obviously doesn't, it's only a hydrogen.
Yep.
So then obviously the carbon would be higher priority versus here there's one carbon and here there's two.
Yeah, yeah. That's
Okay, the
that's
two would have the higher priority. And because this one and this one are on the same side, then it's Z because they're on the same side versus if it was like here and here, that would be an E.
yep.
Okay, so then you're focusing on the center, which is the double bond. Okay, that makes sense.
Mm-hmm.
All right. So you have 8 and 5. And you add them tip to tail. I remember that was like I'm thinking that like if you line them one on top of the other, right? Like 8 plus 5 is 13. And then if you line them in the opposite direction, 8 minus 5 is 3. So it has to be within those two things, right? So that means A is wrong. Yeah, it cannot be 2.
Oh, good. Okay, yeah. Sorry.
I was confused that you were underlining. I was like, if the range is 3 to 13, then the rest of them fall into that.
Good, good, good.
I like started, I don't know, I was trying to like think of like if 8 was the hypotenuse, what it would be, but then if you like line them up on one on top of the other,
Mm-hmm.
what we have to do. Because it said anything.
Mhm.
Okay. Ugh, I hate chem phys. Lasers are optoelectronic devices that emit and amplify light by stimulating the emission of radiation. Excimer lasers. Okay, wait, let's. Lasers emit and amplify light. Okay. Excimer lasers use a mixture of argon and it's iron, two atoms to in a sealed tube at a pressure of 1.52. An electrical discharge provides across a distance of 4.0 millimeters provides 20.6 electron volts of excitation energy to the diatomic compound, which subsequently briefly bonds in an excited state. Okay. So now they're giving us, okay, so the specific laser
Mhm.
uses this at a pressure of this, like in a sealed tube at a pressure of this, in order to emit and amplify light by stimulating, so to stimulate the emission of radiation, right?
Yep, that's
Um,
actually what it stands for. Yep.
and no, I know, I'm just like trying to think it through. An
Yep.
electrical discharge, which they give us um the like the information about here,
Mhm.
provides the excitation energy to the diatomic compound, which bonds in an excited state. This is the wavelength. So
And
now we have EV,
okay. And if you have wavelength, what can you find?
the energy,
And
frequency.
yep.
we have wavelength of 193 nanometers. And we have pressure.
Yeah, they're giving us a ton of values here. So I would maybe wait until they give you like a calculation problem to take a closer look at the values, but just because they're giving us so many here.
Okay. Sounds good. All right. All right, after several passes along the tube, the laser light emits through the semi-transparent mirror. And so then we have this picture. And I remember we had something related to this, I think, where like I remember doing something like this, right? It was the first time we did chem phys, I think. So high reflection mirror, and these are the atoms, and they're what, bouncing off of each other.
Uh-huh.
Is that what is being depicted? And then you have the semi-transparent laser discharge. Okay, so this is a schematic of it.
Yep.
Excimer lasers are used in the photoreactive keratectomy technique designed to correct vision impairment caused by excess corneal epithelium material. Okay. Is that like LASIK?
Yeah, in fact, I used to work at for a laser eye surgeon who did LASIK of different types. And most people get the wrong type, LASIK with an eye. That's when they cut a flap, flip open the flap, shoot the laser, close the flap. All complications from laser eye surgery are related to the flap. LASIK with an E involves dissolving the epithelial layer with alcohol and then shooting it with a laser, and
Okay.
that doesn't have any complications. And but yeah, that's what they're talking about.
Okay. So then why does anybody do LASIK if it has the complications and the other one doesn't?
Because most people like aren't like qualified. Like the guy that I worked with was like he was like super overachieved. He like went to Dartmouth undergrad. He went to Columbia Med. He went to Harvard fellowship residency, Emory fellowship, NYU Stern MBA.
After all of that?
Yeah, Mensa member, and then like a bunch of other stuff. He was also on the show Millionaire Matchmaker and Howard Stern because his personality is kind of makes it so that it's not really easy for people to like him
Oh.
or date him or anything like that. So but yeah, it's LASIK with an I is just more common. Um yeah.
Wait, that's so interesting if there's another one. So then why don't they just learn how to do the like
Yeah,
the
I
alcohol?
I don't know. I think money. I don't know. But
Okay.
yeah, to my friends that have got it, I'm just like, why didn't you tell me? Like, I could have told you like the person to go to. The guy's name is Emil Chin, by the way. Oops.
I think I'm like of the same like how most like of the doctors themselves they don't even get the LASIK because that's like so important that if like God forbid anything goes wrong like
Uh-huh. Yeah. I've always been pretty like cautious about my like I don't like the like when people touch their eyes, I'm just like, don't do that. But yeah, I because when if I worked there, like people who work there, he would give the LASIK surgery for free, but I didn't do that. And also like if I wear glasses, it's like I have eye protection. most of the
Which is like very useful for things like derm when we have like abscesses that are popping on us all the time. But
time.
yeah, I don't know. I
Just
like,
like in general, right? Anything can happen. Things can just you can have eye injuries, so it's a nice
but
thing.
then I just the other day was reading about like a woman who she was like wearing sunglasses and they shattered like during a car accident and she lost her eye because of it.
Oh yeah, because the shattered pieces went into the
Yeah.
eyeballs. Yeah, that definitely is not. It's not a good
I
like.
wear like a good amount of contacts when I'm like actually like leaving the house and doing things other than studying. But then for I don't know, for test day, I know I'm gonna wear my glasses because
Uh yeah, I used to wear contacts also, but then I just got so lazy and I didn't want to keep getting new ones. So
Mhm.
it is what it is. I mean, like I have like my regular glasses that I don't really wear just because, yeah, these. But it's just like since I'm in front of my computer all the time,
The blue light and
yeah, like forget blue light blocking glasses. I'm having it just red light glasses or red tinted glasses because it makes it even more so than
then
black.
blue light, really?
Yep.
But blue light has a higher like wavelength
Does it
than red light, yes, doesn't it? Isn't that the whole point of RGB? R has like 300 and blue has like
the way around? Because smaller wavelengths are more higher in energy.
oh, wait, so
Mhm.
oh, okay, so then red.
Has the longer wavelength.
So oh, so then why do people wear blue light blocking instead of red light blocking?
Oh, just because, well, a couple of things, but blue light, like seasonal affective disorder.
Yeah.
So like therapy for that is blue light therapy because looking at blue light makes your your brain make more serotonin, which can improve your mood, but serotonin also promotes wakefulness and uh therefore can make it hard for people to fall asleep if they're on their computers. So I have
Mm.
like something called flux also, which automatically, as the day progresses, reduces the amount of blue light and makes it more red light, in addition to like these glasses. But yeah, that's why the blue light glasses exist. Because blue light makes you both happy and awake. And yeah, basically.
So then why would we want to reduce it?
Just because it could interfere with our sleep because if you have blue light like at whatever 11:30 p.m. or something like that, it's gonna make it hard for you to fall asleep. Mhm.
Okay,
And like
so
of course it could cause more like strain as well. It's higher energy.
okay, I'm thinking of like, okay, so next time if I'm tired while studying, I'm just gonna take my glasses
Wait, take your glasses. Like what?
off.
Are they? Oh, they're blue light blocking.
Yeah, mine are blue light too on like top of vision.
Mhm. Yeah. Also, if you're feeling sad or whatever, look at some because like what like they sell like those blue light lamps or whatever.
Well,
Or
I'm thinking of like blue light in derm, like we had photodynamic
oh
therapy,
yeah, there's that too. There's like Blu-ray. Um,
like DVDs.
yeah. So DVDs used red light. Blu-ray uses blue light because it's a smaller wavelength and the little dimples on the disc can be more numerous and therefore higher in quality. So blue light, has higher energy, lower wavelength, and things like that. So that's another example of it. There's also red shift, blue shift, which is the that's just what is it? The Doppler effect applied to light.
Okay.
Yeah.
This isn't on the MCAT, right?
Which things? Some of the things sure. Some of the things, no. Um, you know, I could imagine them asking you something about that, about the Doppler shift. Um,
Okay,
yeah. And but yeah, you pretty much know all the stuff that I just said anyway, so
okay. I'm just gonna
mhm.
be really happy when this test is over. That's
Yeah.
just excited to be done. Even though I'm like gonna have a horrible summer taking genetics and calc, so
Oh yeah. Why are you taking
I'm graduating a semester early, and so that like my fall semester isn't like brutal. Since it's my last one there, I want to give myself like a little bit of an easier load and take some of the things now.
like over the summer?
Yeah.
Like but like why those classes? Well, I guess genetics, you're like a bio. Wait,
Yeah, so that's the last one that I have to take for my major.
got it.
And then so when I go back, like because my concentration is general biology, the only thing I'm gonna have left to take is plant biology.
Hmm.
And then I just have to finish my minor, which I accidentally did a climate minor,
Interesting.
like on a complete like random. I was just looking for like a class to take and I ended up like loving the professor. I do research with him. He like I'm doing my thesis. Like he's gonna be my advisor.
You're
And so
doing
we're doing
research
like
on plant stuff?
what?
Or you're doing your research on plant stuff?
No, so that's the thing. I'm doing my research. Like, do you remember when there were wildfires in Canada and then they reached New York and they like there was
Yeah.
like
That's called my scattering.
so there's like there were AQI sensors that were like collecting the air quality data in like the Northeast and they weren't like there weren't as many of them as there should have been. Basically, my professor said that it was going to happen like 10 years ago and everybody looked at him like a crazy scientist. So then after it happened, everyone's like, okay, so like you predicted this. What should we do so it doesn't happen again? So I'm doing like a dual experiment with like he needs help with like the climate stuff and like getting like the awareness out and whatever. And
Mhm.
I'm also like bringing like a pre-med aspect into it and I'm like studying like the lung like health quality like after an event like that, like how
Yeah. Yeah, that's interesting because like the smoke particles are large, which means the light that they scatter would be of a longer wavelength, like red, which is why it appears red. But on a
Mhm.
regular day, it appears blue because blue is a smaller wavelength. And if we don't have smoke particles in our air, the smaller wavelength blue comes out.
Mhm.
So that's like Rayleigh scattering. It's also like if you have, do you have like different, you have like what is it like green eyes maybe or something like that?
My eyes are like
Yeah.
hazel-ish kind of green, not
Yeah. So like eye color, like it's not due to like a pigment, it's just due to scattering of light that comes in because of like yeah, kind of like the same thing as why like the light why the sky would be blue and stuff like that.
that's interesting. I didn't know that. So it like doesn't have to do. I thought it was like just genetics, like your
Yeah, it's genetics and stuff, but
well, I
it
know it's genetics that like
but yeah,
the
it's not like a actual blue or green pigment or anything. It's just like a suspension of particles in that when light goes in and comes back out, it scatters it, um, giving it a type of color. But yeah, that's cool. Are you taking calculus for yeah, why are you taking that?
it's I don't think it's an pre-med requirement, but it's a Cornell requirement. Like my school like said, "Hey, you can't graduate unless you take it." And I took it in high school as part of like an IB diploma and they were like all set to accept it, but then they changed their minds like this year. So I was like, "Okay, let me just
Oh, that's
make sure I have it just in case."
got it. Yep. Yeah, you'll learn about like velocity and acceleration. Because like Newton invented, Leibniz as well invented it, to do physics, to do their physics.
Calculus.
Yep, yep. Yeah, that's really cool. So, all right, let's take a look at where we are up to here.
We were at the excimer lasers.
Mm-hmm.
Are used in photoreactive. Okay, so PRK technique designed to correct vision impairment caused by excess corneal epithelium material. The cornea has an index refraction of 1.3. Material in excess is removed by vaporization from the surface of the cornea with the use of pulled laser radiation at time intervals of 250 ms.
Mm-hmm.
Okay, so they're telling us the refraction, and then the vaporization. Okay. To correct farsightedness, the central portion of the cornea is masked with an opaque disc, so the laser only removes peripheral portions of the cornea. To correct nearsightedness, the laser is directed onto the central part, resulting in flattening of the cornea.
Mm-hmm.
I thought that was an astigmatism.
Which part?
Like when the cornea is misshaped. Oh, but okay, no, I understand. This is like the contacts that you put in like at night and they like flatten out the cornea so you see better during the day.
Okay.
Okay. What effect is produced by the PRK technique to correct nearsightedness? Removal of corneal material at the side. So the radius is decreased, not increased. So this one's wrong. The thickness of the cornea at the apex is increased. Would it push it out more if you're removing from the sides? But it's not the thickness, so it'd be like the diameter.
What? Tell me uh made you eliminate B?
Because if you're taking away from the sides, then the radius of the curvature would decrease, not increase.
Are you looking at the right thing? Like, what's the question stem asking us about?
Far side. Oh. If it's pushed down here,
Mm-hmm.
then it would expand.
Mm-hmm.
So it is B. I was looking at the wrong one. I was like, okay, 2A, great. I didn't read that it was nearsightedness. Okay.
Yeah, definitely just make sure you always read that question stem and enough to like maybe, rephrase it.
Okay. Magnitude of the electric field in the electrical discharged.
Yeah, so that would be a good example of, okay, now let's look at all those values that they gave us.
Okay, so we have the electrical discharge that's 8 kilovolts, right?
Yes.
Across the distance of 4.04 millimeters.
Yeah.
And then the energy is 20.6, the excitation energy.
Do we need that though?
I don't think so. We just need those two values, the discharge,
Yeah.
the distance, and the voltage. Because if you look at the answer, it's in terms of
So when you write like these out, tell me.
kilo and milli, you have to convert to
Mhm.
volts and meters, right? So kilo makes it 8 times 10 to the 4, 80 to the 4.
Why not start with the
3, sorry, 'cause base is the fourth one. So it's e to the third. And then in the other direction, it's -3.
so
So they would, if you divide them, it'll be 2e to the 6th,
yep.
which is A.
Yep.
Frequency of the pulses. Okay, so we have wavelength somewhere here.
Yep.
We have something else. We had something in terms of hertz, no? Oh, we have, I think this is included here. We have the energy, right? Like that's energy is 20.6. But it's in separate. Can I say like 20 is equal to H? HC over lambda. If lambda is 200 nanometers is 200 e to the -9th or 2
So let's make
e
sure
to
we
the
understand what the question's asking us.
okay. Frequency of the pulses that deliver laser radiation to the cornea.
Yep.
That's what's happening here.
Uh-huh.
So we have the time.
Yep.
Index of refraction is 1.3, but it is still this wavelength, no?
So
This is of the tube, but I'm assuming that if it's
so
point
this is yeah, so this
the
is
laser.
a tricky question here because it's not exactly asking us what the frequency of the light is. Right? It's just asking the frequency of the pulses.
Frequency of the pulses. This is the time interval of the pulses. So is it the HF equation?
Well, that would be like what energy is, right?
Right.
But this question's just asking us the frequency of the pulses, which is kind of just asking you how many pulses happen per unit time, essentially. It's a little sneaky here because especially because of what I told you about when you see wavelength of light, think frequency and energy. But this question stem is being
So
kind
the frequency
of
over the time interval, or no?
uh-huh.
Wouldn't you just multiply them? We're looking for.
So frequency is like the number of cycles per second.
Right. So you have
So here we have one pulse.
one pulse per 250 seconds. Milliseconds,
Oh yeah, yeah.
which is the same as 0.25 seconds, right? And then it's 1 over that, which if you convert it to a fraction, it's 1 over 4, right? Or am I like, yes.
You're doing this.
Yeah, because I'm trying to like calculate it out.
Okay.
What it would be.
Okay.
1 over 4, so that means it's 4 hertz.
Yeah.
1 over 1 over 4 is 4.
Okay. Yeah.
That's the I was doing. Sorry if I was confusing it.
Good. So yeah, this is being very coy with the language here.
So I think
Yeah.
like I guess let's say I didn't realize that. I would look at the answers and I would be like, okay, so 250 is coming from here. What is it being multiplied by, but to get that, right?
I think
Because it can't be 250 hertz. That doesn't make sense because it's in milliseconds, not in hertz.
I just mean that from the question, it would make you go look up here first, right?
Mm-hmm.
Because that's where you're looking first. So I think that's what, you know, that's why this is tricky. And if they had some values here that would line up with what we would get, then that would make it a very, very tricky question. But I think that the values won't line up, right? Like let's say we took this 193 nanometer amount and we solved for the frequency of that. If that's in the answer choice, then that is, you know, a way for them to trick us.
Okay.
Because that's where you would go to first, right?
Well, because you've just been like ingraining it in my mind that the first thing you do is check
Yeah,
the
yeah. Mm-hmm. Yeah. So I guess what supersedes that is always like rephrase the question to make sure that you know what the question is.
all right. Okay. Yeah, so what is the frequency of the pulses that deliver laser radiation to the cornea? So then we know that we're looking at the like this part of it,
Mhm.
not at this. So I guess that's like the first mistake that I made, that like as soon as I saw frequency, I went to the wavelength, because you said that when we first started doing this passage, you were like, when you have the wavelength, what can you calculate? And you can calculate the energy and the frequency.
Yeah. So if it was like this, I'll make it 200. Um, this would come out to be like
1/10. Is that 28 or 26? E to the 17th.
yeah, 26, 20
Oh,
to the negative 26 divided by the 193. I turned it into 200, but you essentially get
how did
something
you get 15?
um 8. Oh crap, wait. Well, okay, this and then just one
Plus 9. Were we saying that that was 17?
negative.
Oh, because you changed the units.
No, sorry. Um 1/10 E negative um 15, and then that's 0.1 E negative 14. Basically, whatever this answer is, if it was one of the choices, then a lot of people would get this one wrong. But it's not one of the choices, so even if you do this to calculate the frequency, you're going to see, oh, it's not a choice. I have to do something else. And then you can look elsewhere. But they could
Okay.
just done, yeah, done that.
Pulsed laser radiation in the PKR procedure as exposed to the continuous laser allows. When does it tell us about continuous?
I think they're just saying that, in contrast to pulsed.
Well, I mean, if it's not continuous, let's think of this. It's the same laser, so I don't think it would change the refraction.
Even if it was a different laser, that wouldn't be related to the index of refraction, right? What's the index of refraction like of?
Well, it's like if there's like a from the cornea, like
Yeah,
off of
like the
it.
material that the light would go through, right?
Yeah, so it would
So
stay the same.
that would be like
Um,
the
the
corner.
area exposed to radiation is still the eye. It doesn't change
Okay.
from a pulse. So it's between A and D.
Okay.
I don't think you would absorb more radiation if it's shortened because you're taking in less. So I'm going with D because also that makes sense because if it's like at intervals, then it's not like a continuous thing that like keeps.
Very good. Yeah, a lot of people get this question wrong, and we do see here that excess material is removed by vaporization, which means that you're heating it up, causing it to evaporate, right? So we know that laser would increase the temperature of what it's shooting. So you could do it in a pulsatile way to give it some cooling off time in between.
Okay.
Mhm.
I mean, I was just thinking of it like as imagine like you had a blowtorch in your hand and like if you're pressing it the whole time, it's obviously going to get hotter. And if you're just like flaming it one at a time, then it won't get as hot, which I don't know if that's the right way to think of it, but like
Yeah,
that
because the in between gives it a chance to cool off,
like
right?
cool off, yeah.
Yeah.
Okay.
Also meant like in like video games with guns and stuff, there's like full auto, which is like you hold it down and it's like
And semi-automatic, it's like the chance to recharge.
yeah, or a chance for the recoil to go back. Because if you hold it down, it'll give you recoil that just like will bring the entire gun up. But if you
Oh, because the force is like continuous, so it's only increasing the pressure back on you.
yeah, so if it's semi-auto, it would be like shot and then it goes back, shot, goes back, that kind of thing.
Yeah. Okay. Teacher performed the following demonstration for a lab class. 10 grams of ammonium chloride and 10 grams of calcium hydroxide were added to a sidearm flask. What is a sidearm flask? Is it just a normal flask that's like next to you?
Maybe.
Okay. The
Side,
flask,
that sounds like also like a gun that you have on like your side, but yeah.
the flask was stoppered and heated. So it means it was closed and heated. Ammonia gas was generated according to the reaction shown in the equation. So yeah, so there's the H that comes off. And the oxygen. Okay. L is liquid. So that means this is the ammonia gas. Okay, that makes sense. Calcium chloride is aqueous. Okay. The NH3 gas produced was delivered through a rubber hose to fill a dry inverted 12-ounce aluminum soft drink can by downward displacement of air. The can was then sealed with parafilm and placed sealed down in a shallow tray containing an inch of water. The seal was then removed. As the NH3 rapidly dissolved in the water, the atmospheric pressure crushed the can. The intermolecular forces that exist among the molecules of NH3 gas are. This is my like bond issue where I can never remember. I know that what's it called? That DNA is phosphor it's phosphate and oxygen, right? I had a
Depends
question yesterday, it was PO.
depends on what you're talking about in DNA, right? Like bonds between the backbone that are actual like covalent bonds would be that phosphodiester backbone, but the bonds between the bases would be hydrogen bonds, right?
Okay.
And we
All right.
typically count covalent or ionic bonds as intramolecular.
Okay.
Intermolecular are all those other ones.
That's for which one? For dipole or London? Or we're still talking like general?
So you have like if it's a bond that you use a line to represent, like N H H H, I'm using lines to represent the bonds. So these are full-fledged covalent bonds, like they're strong, right? Now let's say I had a water molecule here and a water molecule here. If I draw something like this, it's not a line because it's not a covalent bond, it's just an intramolecular bond, which we don't use lines to draw. And in this case, it's a hydrogen bond, which is the strongest type of intramolecular bond.
Which one is stronger? The one between oxygen and hydrogen, because you said hydrogens are the strongest.
So what I was trying to show here is that the bonds between, so whenever you have bonds drawn as a line, right? Like this over here or this over here, these are covalent bonds and intramolecular typically. Intra meaning within the molecule, and they're legit bonds. Like they're not, they're not easy to break. However, intermolecular bonds are not as strong, so we typically do not draw them as lines. And the strongest type of intermolecular bond would be hydrogen bonds.
Okay.
So, other types of intermolecular bonds would be dipole-dipole, London dispersion, which is the same thing as
Van der Waals, right?
dipole-dipole would be between two dipoles, and or between two polar molecules, and London dispersion, aka van der Waals, is the weakest and just instantaneous dipoles that exist for instances.
Okay. Now dipole is just like between some sort. I think London dispersion is for all, right?
When you say all, oh, like it's always going to be there, like it's always going to be a thing. Yeah.
Okay. So that means that B, it would go into NH3, but now let's see if NH3 is charged. Or like polar, right?
Oh, I see what you're doing. So you're saying like, so it has to include London.
Yeah, well,
You can get
because it's all molecules, so I'm trying to see. So then D's crossed out too, right?
Oh yeah, true. Yep.
And then I'm trying to see if like dipole is still like a factor too.
Yep. So is NH3, does that have a dipole, aka is it polar, aka does it have partial charges?
So I'm trying to figure out because okay, so H3 is positive, right?
You said
The
what?
3 plus is positively charged. That means that N has a -3 charge.
Mm-hmm.
Would the hydrogens give it a partial positive, or does that just a neutral?
Um, yeah. So yeah, it's going to be
Partially positive.
polar, yeah, which means partially positive.
Which makes it polar, and dipole is present in polar, right?
Yep.
So that means it's C.
Good.
I feel like I made that harder than it needed to. How would you have done that?
No, you actually made it less harder. I would have probably done it harder because what you realized was that London is always present, which eliminates A and D. And then it's just a matter of what does ammonia look like? Like, is it a polar substance or not? And it is a polar substance. So
So once I knew that like dipole has like affects polar molecules, then that was like an easy answer.
yeah,
Okay.
yeah. But eliminating A and D was really good. I wouldn't have thought of that.
Okay. All right. NH3 acts as a weak base in water. The corresponding equilibrium is shown below. Weak base isn't the same thing as a Lewis base, right?
Well,
It is a nucleophile, but that's not what they're asking.
uh-huh.
Okay. At 25 Celsius, the equilibrium concentration of NH4 ion in a 10 molar aqueous solution of NH3 would be closest to which of the following?
Oh, I see what you were asking. So when they say base and when they say acid, they will mean the Bronson-Lowry definition. So proton donor, proton acceptor.
Okay.
But if they say nucleophile, electrophile, that'll be
That's the Lewis. Okay.
or if they explicitly say Lewis. But
Okay.
yeah, when you see weak base, think, it'll accept, protons.
So to solve this, you have to calculate like you have to calculate molar mass of both of these, right? And then set them up in like a 1 over,
Well,
right?
uh,
Like, okay, so 10 molars of NH3 would mean how many of NH4?
so remember when so this is just like law of mass action.
Uh-huh.
Remember that? That's with any capital K.
Okay. I don't know what the level is.
So yeah, so that's when you'll have product over reactant concentration, right?
Law of product over concentration. Okay.
It just all the capital K stuff come from this, and it's really just like product concentration, and if there's a coefficient, that'll turn into an exponent over reactant concentration, and you don't use the pure substances.
You don't, well, this is what we were talking about with the equilibrium constant.
Yep.
That it's not a pure substance.
Yeah, you don't include pure substances. So
So that gets rid of H2O and OH.
H2O,
Why isn't OH a pure substance?
it's aqueous.
Oh, right. So it's only solids and liquids.
Typically, yeah. Well, yeah.
Okay. Okay.
So how would we set this up?
AB is equal to NH3 or no.
No.
NH4 plus and OH over NH3.
Good. And let's say there was like a 4 here,
Uh-huh.
that would turn into
Yeah, that I know.
Okay.
Okay. Can we like cross stuff out? Can we cancel anything?
let's see. So they give us the KB value, which is 1.76 times 10 to the negative 5. And they give us that the NH plus, the ammonium concentration, 10 molar is the
NH3.
Mhm.
10 okay.
And what do we do now? Well, do we need any type of molar mass? Because
I guess not. I just like instinctually, like anytime that there's like molarity questions, I want to find it.
Uh-huh.
But that would take a lot of time. I'm still thinking, like, what if I was to cancel stuff out? Like
okay.
the fact that there's like NH, I want to leave it. So
Uh-huh.
is that wrong? Is that not the right thing to think of?
Tell me what you mean about that.
Like, so we know that this is the like the number of molar, so we have to find it for this. Do you set it? Oh, wait, what if you multiply?
Mhm.
Honestly, I'm confused.
So yeah, the question is,
You want OH out of it, I think, right? Because this is the concentration of NH4. So you want to restructure it to be like NH4 on its own.
now what we can do is we can realize that NH4 amount of that will be the same as the amount of OH minus, right?
Why?
Oh, they have all the same coefficients,
Okay.
right?
Right.
So that means we can set this equal to x and this equal to x
Mm-hmm.
to get x squared over 10 molar is 1.76 e negative 5.
And then you can multiply it by 10 molar.
So then this would just be e minus 4. Yep.
And then square root of that.
Yep. So how would we do a square root of something like this? So we could take square roots or cube roots or whatever roots by using an exponent.
Right.
So how about this? If x squared, if you take the square root of it, it's just x to what power?
If you what?
So I wrote here on the left x squared, and I'm taking the square root of it, would give me x to what power?
Just x. It's x to the first.
Okay. So we want to find out how can we write square root as a exponent. So x
So the
squared,
negative second,
um,
isn't it?
if it was to the negative 2 power, this would be x to the negative 4, right?
Right.
But we want it to be x to the first power, right? So, because when you take an exponent to another power, you would multiply.
Can't remember. This algebra so long ago. Is it 1/2?
Mm-hmm.
Okay.
Because exponent rule means if you take an exponent to another power, you multiply the exponents, right? So 2 times what equals 1, 2 times 1/2, right? So now we can just take the square root, which would be taking it to the power of 1/2, right?
Mm-hmm.
So what would that give you?
E to the second. Yeah.
Mhm. Oh, and then the 1.8 or whatever, we can put some like,
Like 2.
yeah, or like, you know, 1 point something. All the choices have a 1 in it, so we could just have it.
Say 1.
Mhm.
1 e to the negative 2.
Mhm.
0.01.
Yep.
There has to be a quicker way to do that, no?
Nah, not really. I mean, it's not that time consuming, right? It's just,
I know, I'm just trying to think like why I
Mhm.
don't think I would have been able to figure that out if you didn't help me through it.
So just, yeah, so remember when what I say about law of mass action, because that's going to deal with every type of capital K. And they'll ask you questions like this also with like KSP, and let's say it's like CaCl2, breaks down into something that would be like, this would be x, this would be 2x squared. So if you multiplied that, you would get 4x cubed. Yeah, there's in the shared PDF folder, there's a PDF called How to Do Calculation Problems, and I include like this type of thing.
Okay. All right, so I should take a look at that.
Mhm.
Should we stop?
Yeah. Or let's see if, well, I was gonna say maybe those last two, but it's okay.
Oh, no, sure, let's go through it. Here, let me reshare, sorry. Okay. I forgot that we were doing a passage one.
Hi.
If methane were substituted in the aluminum can, the crushing can would CH4 is polar, right? Because H has the partial positive.
Mm.
Is that like an agreeing or a disagree?
So C has 4 bonds to hydrogen. So they should all be pulling.
Oh, because it's 4, it's neutral.
Mhm,
That makes it non-polar.
mhm.
So B and A are wrong. C and A are wrong. Now, would dissolve in the water in the tray. So it's whether it's hydrophilic or hydrophobic, which I don't know.
Well, you mentioned polar and nonpolar,
Polar,
and like dissolves like.
huh?
Oh, so you mentioned polar and nonpolar, and we know like dissolves like, meaning polar things will dissolve in polar stuff, and vice versa.
So but NH3 was polar,
Yep. And
and
what
this is
water?
non-polar. Oh, okay. So if this dissolves, then this wouldn't dissolve.
Yeah, because water is polar, right?
Right.
And that's why polar things would dissolve there.
Yes.
But yep, CH4 is
Okay, so that one's easy. You just have to think.
yeah. Yeah, that's the test, right?
Yeah.
Okay.
Right. Oh, I was like, how did you already cross it out? Um,
Yeah, this is a kind of
okay,
like
so it's not transition.
not a very good question, I would say, but yeah. Do you remember what the metalloids were?
CaOH. Metalloids are here.
They're like
The alkaline earth is there, right?
this stuff
Uh-huh.
is,
These are the transition.
yeah, these are the transition. They all have d orbitals. These are non-metals, and then this kind of line here are the metalloids, which have properties of both. And then the first one, second one, will be the alkali and alkali earth.
Which Ca is here and hydrogen's here, but O and Cl is here. And since these have greater concentrations, I want to say metalloid.
Oh, well, they're asking about these, right? And the calcium, right?
Yeah. But isn't
Because
the
OH,
concentration part what's important here? Like if O has, you're gonna hate me for saying O molar mass. But if the compounds, like if there's more oxygen than calcium.
well,
Oh, but wait. So it has calcium, oxygen, and
Yeah, oxygen is a
hydrogen.
non-metal. Oh, like so the OH is a non-metal, the chlorine is a non-metal, but we don't have any choices that say non-metal. We only
Mhm.
have choices that are transition metal, metalloid, alkaline metal, alkali earth metal. And what the two things that they're asking us have in common is calcium. So question effectively then just becomes what group is calcium in?
Okay. So is it alkali or alkaline?
So yeah, group this first one is alkaline, and the second one
Alkaline.
earth.
Calcium,
Mhm,
alkaline. Is that the answer?
mhm.
That one was weird.
Uh-huh.
I think it, yeah.
Yeah. Yeah, and alkaline earth metals typically make hydroxides, so that's what you'd see with the OH, but yeah, awesome. Okay, so let's see. Um, don't do anything tomorrow, like unless it's like Anki. How is your like sleep?
Fine. I'll probably go to bed like a little bit earlier than usual, just so I can have like
Yeah,
I
because
think as far as test anxiety goes, like I was fine. Like I don't really.
you definitely don't seem like, you're getting like burnt out and stuff, but so that's good. And you're saying you get enough sleep. Yeah, because the night before the test, people typically fall asleep later. So I would recommend going to bed earlier by a couple of, hours or something. But yeah, tell me how you feel about all this.
I think I'm gonna do Anki and just like flashcards to make sure. Like I think amino acids I have to do some practice with just to make sure that I understand everything there. When you were telling me like the branching stuff, that helped a lot. I think I've seen questions about that since we've gone over it and now I know. I think like I just hope that everything that we've gone over like in the last like 2 weeks is really sticking because like I don't know, I feel like law of retention is just
Mhm.
stuff that are like from earlier on I remember a lot better than like I don't have time to like repeat them as much in my head.
Yeah, so definitely make sure you know your units and your formulas. When I say units, I include like the prefixes,
Hmm.
because today, I don't want to just say like, or freak you out, but like the nano, you definitely want to know
Yeah, I have to make
what
sure
it is,
that I yeah.
micro and things like that, right? There's like a mnemonic, I forget, but it's some like King Philip, something like that.
King Henry died drinking chocolate.
That kind of thing. So yeah, know that, know your units, know your formulas, right? Um, so definitely, yeah, know those. Always try to rephrase the question just to force yourself to really understand what the question's asking for. Um, don't rush.
What's between milli and nano?
Million nano, there's
Yeah,
micro, which is a millionth, and
micro and nano. Okay.
yep.
Because so then micro is
That's with the mu.
yeah, I know. I'm just thinking so milli is to the negative third,
Mhm.
mu is -6, and nano is -9.
Yeah, and pico is -12.
Yeah. I've never seen pico come up.
Yeah, I've seen it come up um maybe like twice. So, but I haven't seen anything beyond that. Um, but yeah, that and your formulas, make sure you know your formulas and yeah, read the question stem very, very carefully because you've seen how the MCAT really likes to test
Yeah.
uh nuances in language. Like today, the most nuanced one was the question about the pulses,
Mm-hmm.
because you know it was asking about the pulses at which the laser like actually shot, not anything about the light itself. the frequency of the light itself.
Mhm.
So yeah, be very careful about like the subtle nuances in language. And you say timing you're pretty good with,
A
right?
little too good. So I need to take my time and actually like look through things
Yeah,
and
yeah,
utilize flagging where it's like if I am guessing and then I have time left over at the end, I want to come back.
yeah. Did I talk to you about like the timing checkpoints or maybe?
Like the when it gives you the 30-minute warning and the 5-minute.
Oh yeah. Yeah, I was gonna say like when you get to question 20, check the clock and you should have like an hour left. And that gives you a chance to adjust your pace.
Okay.
And when you get to question 30, you should have like 45 minutes left. It gives you another chance to check your pace or adjust your pace. And then the last one would be when you're up to question 40,
Mm-hmm.
have 30 minutes left. So instead of constantly having your eye on the clock, you have 3 designated checkpoints at which you'll do that.
Mm-hmm.
And yeah, if something is taking too long or you're not 100% certain of, flag. Yeah, make an educated guess, flag. And it's better to have extra time at the very end than, let's say, like 20 minutes for like the last 2 passages because the passages and the questions differ in difficulty and time. So, once you're finished with question like 59, you could hit view flagged and then go through the flagged ones and with your own appraisal of like, okay, I flagged this one, I'm 25% sure. I flagged this one at 50% sure. Go through the ones that you're less sure of. Uh,
Okay.
and yeah, learn those psych-social terms and be aware of the trap answers. Like, be aware of, uh, that type of thing. Of things that might seem too obvious or seem too explicit from the passage. You know,
What about for biochem? Do you have any advice there?
yeah. So I guess like other than what I
Trap
said,
answers.
it would be like writing the proportionalities, right? Um, writing schematics if you need to, when analyzing tables and graphs, like if you also do like greater than sign, that kind
Mm-hmm.
of thing. But yeah, the proportionality stuff.
And then you were saying the p-values, anything below 0.05 is significant. And so if you're on a time crunch, only look at the significant.
Yeah, yeah. Sometimes they might want to trick you. We had a passage where the asterisk was like something else. So like
Well, right. So you have
always
to
be
look
on the
at like
lookout for.
um the little like blurb under just to make sure the
Yeah, the
description.
captions and stuff. Yep, yep, yep. Yeah. Yeah.
Okay.
That was yeah. And yeah, and like look over like oh, and then yeah, make sure that oh yeah, those functional groups. Know your functional groups. Know those types of reactions. I don't know if I shared this resource with you, but I'm putting it in the chat. It's like a pretty short kind of orgo review with certain things, but you need to know like what the functional groups are, what they look like, and that includes all the ones with like the carbonyl groups.
Okay.
Um, you know, think about that hydroxyl group, very good nucleophile. So you're definitely going to see things like that. So know that type of stuff. And yeah, I think that's it for the most part. Anything else that comes to mind?
I don't know. For me, I just like need to be careful and like the information that I have, make sure that I'm using it correctly and not just like
Yeah, yeah. Yep. Yeah. I would say just yeah, to measure twice, cut once, that type of thing.
yeah. And
But
then
yeah.
no stupid calculation exams. I should look over like your calculation PDF.
Hmm. Yep. That can, yeah. Look over the PDFs that I have in general. I guess that can also help. Especially
I
with
just don't want to like overload myself in the last 2 days. Like there's
exactly.
really a lot that I can learn now. Like
Yeah, exactly. So
solidifying stuff that I've already like seen.
yeah, yeah.
In my
So I
head.
would say just, chill out from this point. Like if you're going to do anything, do like a passive review, like look at notes.
Ours practice.
Maybe Anki. I don't know about cars practice because that would be like doing something and you know that might, and you if you don't get them all right, it might put you in a bad state. So I think doing practice, we just want to kind of do passive stuff, but yeah, do like Anki and stuff like that. Go through like passively go through like notes and things like that and
Sounds good.
rest and yeah, I think you're gonna kill it. I think you're gonna do
No, hopefully.
so
All right.
tell me
Okay.
how it turns out and
Yeah, I'll text you after I take it. Just to...
Yep.
Okay. All right.
So
Bye-bye. Thank you so much for your help. I really appreciated it.
yep. Take care.